Good morning, good afternoon, good evening. We are back and we are definitely better than ever. Today we are talking about intersecting lines and relationships between lines. This is awesome. If two lines intersect, then they have a point in common. And we've done this before in class, but I just wanted to get an example on video. Okay, so line 1, we know that x, so I'm going to put line 1, we know that x equals -2 plus 3s. And in line 2, we know that x is equal to 15 minus 4t. In line 1, we know that y equals 1 plus 2s. And we also know that y is equal to, in line 2, we know that y is equal to 5 plus t. Okay. Well, if these lines intersect, that occurs when this x is equal to this x and this y is equal to this y. And so if we equate the x's, we get this. And if we equate the y's, we get this. 1 plus 2s equals 5 plus t. And then if we do some algebraic manipulation, like, let's see. I'll move the fourth, so I'm going to have 3s plus 4t is equal to 17. And then if I have here, then I will have, let's see, 2s minus t is equal to 4. And then to solve this, I'm going to multiply this by 4 because then the t's would drop out, and I would have 3s plus 4t equals 17. 8s minus 4t is equal to 16. The s or the t's would drop out. I could solve for s. I will tell you that s is equal to 3. And then substituting that back into either of those equations, I get t equal to 2. And I'm not going to show you how to do that because you've done that 1,000 times. Okay. Relationships between lines. In 2 dimensions, lines are either intersecting, like here, parallel, or coincident, which means they're the same line. These are 2 lines, one on top of the other. Okay. Here, if the equations of these lines have one solution, that's that intersection point right there. There are no solutions to these 2 equations. And here there are infinitely many solutions because the lines are the same. They're on top of one another. In 3 dimensions, lines are coplanar if they lie in the same plane. They lie in the same plane. So let's see if we can get examples of that. Okay, let's get some lines right there, and we'll go red. Okay, so for example, if you think of this front box wedged into this 3-dimensional graph, we'll say this is x, this is y, and this is z. Okay. So if I have a line here in this plane and a line here in this plane, they are coplanar. They're in the same plane. Okay. So these lines, we have different classifications. Those lines could, let me delete that one. Right now those lines are, right now these lines appear to be parallel if they're in the same plane. So they're either parallel. We could also have lines that in the same plane that intersect right there in this plane that's the front of this cube, or we could have lines that are coincident right on top of one another. Okay. Okay. If lines are not coplanar, they are skew. Well, that's kind of weird. What would skew lines look like? Well, let's say I had a line right here. Okay. And it's easier to draw right on that edge. But it's in this front plane. Well, if I have a line right here that's in this other plane, this side plane, you can see how this line here would go in front of this line going up and down. Those are skew lines. Okay? If lines are parallel, the angle between them is 0. That's easy. If they intersect, then the line between, or the angle between them is theta, and we always use the acute angle here, not the obtuse angle here. That's how we name that angle. Okay? Now, I don't like this drawing. Don't look at it. Okay? But if we have two lines, okay, and hopefully I'm going to be able to grab one of these lines. Nope. Oops. Let's move this back. Okay. So if we have skew lines like this one, and we take that line, and let's make him thick so I can move him. Okay. So if we take that line and we pretend like we translate it, we define the angle between the two lines, and now they intersect. So let me make him thin again. Okay. We defined as the angle between the intersecting lines. So this angle, we pretend that they intersect, right? We translated this from over here, where, you know, and then until they intersect, that's the angle. The angle that is formed is the angle between the skew lines. In this case, it happens to be perpendicular, just because I drew them perpendicularly. But remember, we translated it. Remember, it's big. It moved from over there over to here, and when they intersect, that's the angle between this skew line and this skew line. Okay, so let's have a little bit of fun. Line 1 has equations blah. These are parametric equations, and line 2 has these equations. Show that the lines are parallel but not coincident. Okay, so I'm going to write these in vector form. So I'm going to have r for line 1 is equal to negative 1, 1, 1 plus, let's see, s times 2, negative 2, 4. And then line 2 is going to be r is equal to 1, 0, 3. Plus, now I have to use a different parameter, that's why I started with s, so I'm going to use t, and let's see, that's going to be negative 1, 1, negative 2. Okay, so let's show that the lines are parallel. Well, if lines are parallel, then their directional vectors are multiples of one another. So if all I have to do is say negative 2, or 2, negative 2, 4 is equal to negative 2 times negative 1, 1, negative 2, and maybe one step further, just go ahead and multiply this out, which is negative 2, I'm sorry, that's positive 2. Negative 2 times negative 1 is positive 2. Negative 2, positive 4. So this shows that they're parallel because one directional vector is a multiple of the other. But not coincident, okay? Meaning they're not the same line, okay? So let's go with let's get a point on line 1. On line 1, I'm going to let s equal 0. If s equals 0, then I get negative 1, 1, 1 as a point because all of these go away. So I have the point negative 1, comma, 1, comma, 1. That is on line 1. Okay? Now what I do is I select really any of these, and I'm going to make my life easier, okay, to be on line 2, and I'll do line 2 in red. So line 2, okay, I'm going to select the point, the y-coordinate 1. Okay, I just didn't want to deal with the negative, so I moved to the y. Okay, so this, okay. And again, I have to select any 3 of these points. So if this equals 1, the y-coordinate equals 1, I'm going to look over here. Maybe I should say x, y, z here. Maybe that makes it a little clearer. I know that y is equal to 0 plus t, right? Well, if y is 1, then 1 equals t. Okay? So for t equals 1, that generates the y coordinate of 1. So when t equals 1, what does y generate for the other coordinates? Okay, so 1 plus, I'm doing the x coordinate now, 1 plus 1 times negative 1 is 1 minus 1. That is 0. Okay, and then 3, let's see, 1 times negative 2. 3 minus 2 is 1. I get the point 0, 1, 1. So I have the same y coordinate, but I have different x coordinates and different z coordinates. All I need is one difference. Okay, that is enough to show that the lines are coincident. If you had to write it out, you could say since negative 1, 1, 1 is not equal to 0, 1, 1. Oh wait, these are the same. Oops, these are the same. But sorry about that. But I have one difference here. Since this is not the same coordinate as this, and I've shown they're parallel, they are not coincident lines. Okay, I'm going to stop, take a pause, and we only have one more example to go.